7:30, and we will be starting soon. Just hoping that you all are staying dry from all the bad weather that we have been getting in South Florida. We will give them a couple of minutes to let other people join in. So I guess we can get it started. Good afternoon and welcome everyone. Welcome back to some of you. This is our 5th installment of the School Garden Leadership Training. And today we will learn about the skin of the earth, meaning the soil and vermicomposting. Today is November 10th and we're recording this presentation. Next slide, please. As previously done, please type into the chat your name, the county you are watching us from, and tell us your experience with compost and or vermicomposting. We will use this information as proof of attendance for your CEUs. Next slide, please. Before starting, here are some housekeeping tips. At the bottom of your Zoom screen, you will see the chat box to type in your questions. And we ask you to please turn off your video and audio to avoid interruptions and technical glitches. Next slide, please. So this training is designed for Florida school garden leaders of all levels to build gardening confidence, to foster collaboration among leaders, and strengthen garden programs for long-term success. Next slide, please. This series of virtual school garden leadership training for the 2020 and 2021 school year is provided by the University of Florida IFAS Extension Family Nutrition Program and the Florida Agriculture in the Classroom. Next slide, please. So what is FNP? For those newbies we have today, we are the University of Florida Institute of Food and Agriculture Science Extension Family Nutrition Program. We are known as FNP, and FNP provides free SNAP education in Florida, including classes in Spanish and Creole. We have provided free nutrition education to SNAP-eligible people in Florida since 1996, and we are currently teaching in 40 counties. Next slide, please. Our mission. In FNP, we help limited resource families in Florida to access more nutritious food choices on a budget and adopt healthier eating and physical activity habits to reduce the risk of obesity and chronic diseases. Next slide, please. So the session overview. For today's session, we ask you to wear your science hats because we will explore the science behind soil compost and vermicompost with Dr. Wilkie. Then Lee County teachers Susie Hassett and Shelly Hassett will share their experience and tips for composting and vermicomposting at school gardens. We have also included a do-it-yourself session with WARN expert Rachel Singletary, and at the end, we will be providing an optional Q&A session. Next slide, please. So feel free to put your questions into the chat. We will not be stopping for questions during the presentation, but we will try to answer as many from the chat box as possible at the end of the presentation. We will be available after this presentation for a 30-minute question and answer period. So we have 4 wonderful WARN experts and lovers that accepted to present for you all today. I will introduce each of them. We have Dr. Wilkie with us today. She is a research professor at the University of Florida in the Soil and Water Science Department, and will be introducing us to the science behind soil and composting. Joining us today is also Rachel Singletary, our WARN expert. She is a WARN farmer and vermicompost instructor who will show us how we can make our own vermicompost bins. So we hope that you have your materials ready with you. We send the list of materials via email, so you have it in your email, and you will also have it in the Google Drive. We are also very excited to have Susie and Shelly Hassett, mother and daughter who share a passion for science and warmth, of course. Susie is an environmental education resource teacher, and Shelly is a science resource teacher at Littleton Elementary. Susie and Shelly will be sharing their teacher experience and tips for composting and vermicomposting at school gardens. Next slide, please. Your facilitators for today is myself, Carlita Fiestas, and I'm the food system specialist for the Family Nutrition Program in the Southeast region. So I oversee Broward, Palm Beach, Martin, and St. Lucie counties. We also have the amazing Kelly Wilson, my counterpart in the Southwest region of Florida. Kelly oversees Lee, Collier, and Charlotte counties. So if you are from any of these counties, feel free to reach out to us with questions about your school gardens. Next slide, please. Okay, now I will handle it over Dr. Wilkie.
Okay, then. Can everybody hear me? Yes?
Yes, we can hear you fine.
Well, good afternoon, everybody. Very pleased to be here. I've known Carlita since she was an undergraduate here at the University of Florida, and we have worked on composting together. So it's certainly a great pleasure for me to see that she's out being one of my disciples, promoting composting out to teachers and students. That's wonderful. Greetings from Gainesville. Carlita mentioned that I'm a professor of bioenergy and sustainable technology, but another thing that might be relevant would be that I operate and run a student compost cooperative here on campus. And that's a facility where students, staff, and faculty can bring their food scraps here to a facility outside my laboratory. We generate compost, and we then use the product in our organic gardens, which are nearby. And in case I tend to forget at the end, I would like at this point to say that any of you teachers out there are more than welcome to come to my lab, bring your students and come and experience what we have here, and it might help to give you some ideas about setting up maybe a compost facility at your school, which incorporate maybe other aspects of sustainability. Next slide, please. I'm going to talk today about composting, obviously, but I want to say that there are two things about composting that are very important in terms of teaching society and kids in general, is that we have the ability to reduce organic waste, and at the same time we have the ability to make a great soil amendment. So we're solving a waste treatment problem as well as generating a soil amendment. Now, to understand the reason why we need to compost, I think it's important that we need to review some facts about soil, given the fact that we're making a soil amendment. What exactly is soil? Soil is really like the epidermis or the skin of the earth. It's more than just dirt. People tend to refer to soil as dirt, but it's more than dirt. It's a complex mixture of fine rock particles, organic matter, air, and water. Next slide, please. Good garden soil that we have has about 45% mineral content, 5% organic matter, and about 40 to 60% air and water spaces in the soil itself. You see here, I've used the term or the organic content of 5%. That's kind of really good garden soil, but most of our soils here in Florida are really sand. So typically our organic matter content would be more like 1 to 3%. The void spaces in the soil itself hold air and water, which are part of the soil solution that is essential for microbes to function in soil itself. Next slide, please. The soil, the organic matter content, is teeming with soil organisms. They are bacteria, fungi, actinomycetes, and earthworms, which are the master tillers of the soil. It's very much alive. It's not just dirt. It's important as we teach children about composting for them to understand that. It's full of all these organisms, bacteria, the fungi, the earthworms, and those organisms naturally in the soil spend their time feasting on organic matter. These organisms power the natural decay cycle, recycling nutrients, mixing particles, and maintaining healthy soils, which are necessary for us to produce food. Next slide, please. We talked about the organic matter content and how that's important for a productive soil. Well, here's how organic matter is formed in nature. As plants and animals decay, and here you see like weeds, dried leaves, or manure, as the organisms that are in the soil feast on these organic residues, the organic residues are converted or decomposed into organic matter, and you'll see the color changing to this half decomposed material to this ultimately decomposed, darker coffee colored material. Okay, if you look to the bottom, you see a slide that says soil poor in organic matter content. You see the color is much lighter, and this is very typical of our sandy soils in Florida. Next slide, please. Organic matter. Look at that wonderful, rich organic soil. The organic matter, the simplest definition is that it's a term for both the living organisms of plant and animal residues in various stages of decomposition in the soil itself. Organic matter is what makes soil work. And this is why we want to make compost from our own organic residues. Organic matter is important for maintaining soil structure, and that enhances the movement of air and water through the soil profile itself. Next slide, please. Okay, composting. In its simplest terms, compost is a rich mixture of organic matter that can be kitchen waste, plant residues, grass clippings, all piled together so that it rots down to a very fine, crumbly consistency. The end product of composting is a soil amendment, basically decomposed organic matter. And when you build a compost pile or a compost bin, you intervene to speed up the natural process that would occur if this material was just thrown on the ground. That's what allows us to kind of engineer being able to generate a soil amendment in a short period of time. Next slide, please. Thank you. Okay, so now we want to compost. Just like anything, if you want to bake, what are the ingredients we need to use to make this compost? So we need air, we need water, we need brown stuff, and we need green stuff. The microbes that are responsible for the composting, the bacteria and the fungi, they need a mixture of brown stuff, and brown stuff we'll define as carbon-rich materials such as dead leaves or paper. The green stuff would be nitrogen-rich materials or ingredients, and they would consist of like food waste or fresh grass clippings. And these are the things that the bacteria need to munch on. Put all these things together, the brown, the greens, the air, and the water, and in no time, you'll have a very happy compost environment. Next slide, please. Okay. We mentioned greens, we mentioned browns. Again, greens are very high in nitrogen, they're more moist. The browns are high in carbon and they're more drier. So let's go through these and see. And this list is by no means extensive. It's just to give you some idea of what you can use. Kitchen scraps, fruits and vegetables, potato skins, vegetable peelings, apple cores. I see that I haven't mentioned banana skins there. They would be a good ingredient as well. Coffee grounds. Coffee grounds are very good because they're very high in nitrogen and they will add a large amount of nitrogen to your soil. Tea bags, eggshells. Eggshells are wonderful too because they're very high in calcium and magnesium and they help dampen out any pH issues that you might have. Grass clippings. And then over to the browns. Newspaper. Normal office paper. We do a lot of composting here of shredded office paper. We also use shredded and torn up cardboard. We get a lot of packages that are delivered here to the laboratory. Dead leaves, prunings, small twigs, hay and straw. So mixing a balance of high carbon and high nitrogen is key to having a good and fast compost system. High carbons materials again tend to be brown, they tend to be dry, and the high nitrogen are green and they are more moist. Next slide. Okay, they're ahead of me. Great. Okay, getting started. How do you actually start this gem of biological activity? The best way to activate the process that I have found is by adding a few handfuls of good topsoil or finished compost. If you get your ingredients, your browns, your greens, mix them together, put in a few handfuls of either the topsoils, or if you've got a previous batch of compost, you could add that. That can work very well. And I have found that to be a universal starter and to get the process started. Now, if you want to get started faster, you can actually increase the amount of topsoil or compost, compost that you'd like to add. Okay, next slide, please. The essential components of composting there are, you've got to add the materials, and then you've got to actually add materials, hopefully that are broken up or diced in terms of converted into a smaller size. To get the science behind the green and the brown, let me tell you this, that the greens provide the microbes with nitrogen to build their cell mass. The browns, on the other hand, they provide the microbes with carbon for energy. And the ideal carbon to nitrogen ratio for a compost is about 25 to 30 parts of carbon for every 1 part of nitrogen. And to achieve the best CN ratio in your compost, the rule of thumb that I use is that I put in 1 or 2 parts of brown material for every 1 part of green material. How do I come to that? Well, if your pile has too much carbon material, like what we call the brown material, the pile will be drier and it takes longer to break down because the organisms need moisture to be able to grow and reproduce. Too much nitrogen, on the other hand, like just food waste on its own without a carbon source, that can actually create a slimy, wet, and a smelly compost. And that's not compost, that's just decaying food waste. So you've got to be able to have a mixture of the greens and browns. And what I find is that by chopping up and adding the shredded paper to the food waste, the paper tends to absorb the moisture in the food waste, makes it more manageable. There's no kind of loose water per se, and the material is moist enough, but it's not too dry. Surface area, why is that important? Well, just like ourselves, if we're trying to eat something ourselves, we usually munch it and chop it and reduce the particle size in our mouths. So in this case, microbes are very small, so it helps with the process and it speeds it up if you actually dice the food waste or chop it up. So there's more surface area available for all those microbes to work on. Next slide, please. So the key to effective composting is to create the ideal environment, and they need moisture, they need the aeration, and they need the temperature. Why is that important? Because again, bacteria need water to survive, but they don't want too much water. And therefore, I use the term on the slide here, slightly moist, like a run out sponge. You don't want loose water. If you have free water in your pile, add more cardboard or paper or leaves to absorb that water into their structure. Aeration is important because the bacteria that are doing this work are aerobic organisms, and basically they need the oxygen to breathe. That's why you turn over and mix the pile so that air gets in at various places. Temperature is important too. The higher the temperature, the more faster the organisms will grow. And we're fortunate with that in Florida, is that we have high ambient temperatures, and that allows the process to be more prolific. And indeed, it's one of this high temperature we have in the state is one of the reasons why too we have to continually put organic matter in our soils, because the high temperature and humidity increases the rate of decomposition. And therefore, you've got this need to continually add a soil amendment to our sands. Next slide, please. So we talked about soil is important. The organic matter content of soil is important. We have a high temperature and humidity in Florida, or organic matter in the soil is continually being turned over and decomposed. We have a need to replenish that for our soils to remain productive for plant health, and adding a compost amendment is a way to do that. So compost is nature's best soil conditioner. It enriches the soil with nutrients and organic matter. The organic matter retains moisture, which we need for plant growth, and it helps prevent nutrient leaching. So the nutrients are retained for plant growth rather than leaving the pile. The other thing that's important is that from a holistic environmental point of view is that reducing the amount of waste going to a landfill is also good in the production of the soil amendment, because by diverting the food waste from a landfill, you're decreasing the amount of greenhouse gas emissions that might come from that landfill, that would come from that landfill if the food waste was buried in the landfill itself. Also, compost provides sustainable alternative to commercial fertilizers, which cost money and don't add anything to the soil other than actual nutrients. They don't contribute organic matter or contribute to soil structure or to soil texture. Composting teaches our students how to care for the environment and live in a more sustainable way. And I think that is really important for us to pass on to the younger generation. Next slide, please. Now turning to worms, of course, a pun on the fact that earthworms are always turning over the soil, is earthworms are intimately involved in the shredding and digestion of organic matter on the soil in the soil profile itself. They're always moving the soil. They're producing castings which help the soil stay together. We call it soil aggregation. And they're moving the organic matter from the bottom to the top. They're mixing the soil. And now they're going to mix our vermicompost bins. Next slide, please. Vermicomposting is feeding earthworms is a good way to make high quality compost from food scraps. The regular compost is fueled by the microbes from the soil. In this case, vermicompost is fueled and moved by the earthworms themselves. The worms suitable for this type of composting are small red worms, and they're commonly known as red wigglers, not your typically soil earthworm per se. Next slide, please. So these are the advantages of vermicomposting. If you just think of all the things that they can do. Vermicomposting is a composting process mediated by worms. The worms produce a rich organic soil amendment containing a density of nutrients and beneficial microorganisms. The worms are basically placed in a bin full of high fiber bedding material, such as moist newspaper or shredded office paper. They eat through this and any kitchen waste that's added. The worms produce droppings, also called casts, that are high in nutrients and very high in microbial counts as well. So they add bacteria to the soil, which is a good thing. Because the earthworms tends to turn the soil, the vermicompost doesn't need to be turned by us because the worms do all the mixing for us. So that's an advantage. And the worm bins can also produce an excess liquid. Sometimes we call that leachate, and that can be used as a plant feed. Vermicomposting has a lot of advantages, and in particular, one that I found myself is that when space is limited for a compost pile outside or maybe a large compost bin, the vermicomposting becomes an attractive option because you can actually use that inside as well. You can use it on a porch, on a veranda, or even on a step. But on top of that, I think for teachers, vermicomposting can be a powerful educational tool for teachers because it allows them to teach about decomposition. It allows them to teach about microbiology. It allows you to teach them about earthworms, soil, and the importance of managing organic residues such as food waste at home. Next slide, please. All right, I sense I may have gone on too long, but I enjoyed giving you this short talk or chat about composting, soil, and vermicomposting, and I put together some sites for you to look for further information. And my information is there at the beginning of the presentation. If you really want to have more questions and we don't get a chance to answer them today, please feel free to email me or call me. And as I said, we would love to host you teachers and your students here in Gainesville to see our facility and let the students play with our compost and our earthworms. I'll finish there and thank you very much.
Okay, thank you, Dr. Wilkie. Thank you for your presentation and sharing those resources for our teachers. That was great. We are sharing the links with you all in the chat box. And now we will continue with the section of Susie and Shelly Hassett from Lee County. Next slide, please. So Susie and Shelly prepared a presentation for you all. However, to avoid technical glitches and as we were expecting really bad weather, we will show you videos that they kindly put together to share with you. Go to next slide, please. In the video, they refer to the types of compost containers. And next slide. And also what goes into the compost pile, as you can see in this slide. So please don't worry if you cannot take notes. This PowerPoint is going to be shared to you via Google Drive as a PDF. So you will have access to these slides. And Susie and Shelly are here to answer your questions. So if you go to next slide, we can now play the video.
Hey, out here at the Littleton Garden, we've got a couple of different ways we compost. You can just make a pile in the corner of the garden. When we first started, we just had a fenced off cage where we threw the compost and we turned it over with a shovel and a pitchfork. But we got some really cool rotating composters. This makes it pretty easy. You can keep it all contained in one place. Whatever you do with compost, you want to keep it all contained in one place. You want to keep aerating it by turning it, and you want to keep the vermins out of it. So find some way to cover it so that the raccoons and things don't dig in it. So this one has a locking lid. We can open the lid up, and then we can add our materials. So you need brown and green materials. So the green can be weeds that you pulled. It can be your cafeteria food. So our cafeteria folks collect food that's going to waste, that they're going to throw out, things that have started to go bad, and they bring it over so that we can compost it. So this is a little bit frozen still. If we have more than we can use to feed the worms or put it in the compost, we put it in the freezer until we're ready to use it. And we have a constant supply. This is some old lettuce and broccoli and cucumbers. So we do a layer of green. And if I was putting it with the worms, it would not still be frozen. And then we do a layer of brown. The custodians also bring any old leaves out here. So leaves and twigs that they've raked up can come out here. And we have found out that you can use some other things that would be considered the brown part of compost, like our dryer lint. We break that up. The dryer lint is from the cotton towels, so I know it's from plants. And shredded paper can't be recycled because the pieces are too small, so we can add some of the shredded paper to this, and of course we use it in the worm bins to cover up the food that we add to the worm bins. And then the last component is water. Make sure it's nice and wet. Not as wet as a wet washcloth, more like a damp sponge. So we sprinkle it, get it damp so those microbes can do their work. Lock the lid so it doesn't fall out. And then we give it a couple of turns to aerate it. It has holes that we can open and close to let more air in, because you want those aerobic bacteria, not the anaerobic bacteria. So every time we add stuff, we give it a couple of tumbles, and then it gets all mixed up nicely. You might be able to see in there. And those decomposers do their stuff and turn all that plant material back into building blocks and nutrients. That's all you need.
Hello, my name is Shelly Hassett. We're here at the Littleton Garden looking at the benefits of composting. So here in front of me, we have a sampler tray of 3 different soils from this area. So first, we have our natural Florida soil, which is going to be very sandy with not much humus. You can see our bits of fossil shells. This came from the pea field, just right over there. Not a lot of plant cover on the pea field, so whatever humus was there gets washed out by the rain pretty easily. Over here, this comes from right here under the oak trees, and you can even see in it the pieces of the acorns and the leaves. So we're starting to get darker, more humus with more of that plant cover, consistent plant cover, but it's still not as rich as what we want to be growing vegetables in. Here is some of the soil from our compost pile, where we used to have our compost pile over here. And you can see it's mixed in really nicely with the sand. You can still see pieces of sand, but it's also much darker and richer with more of that plant material, that humus in there. Now, one really fun activity to do with second grade when you're talking about soil composition is to give them these samples to compare and contrast, and then have them make a little swatch, make a little mud with it, and then literally just rub it on the paper. Super messy, very kid friendly. And what you're gonna find is that our soils with the greater humus content are gonna show up richer and darker on the paper. This sample I have in front of me comes from our rotating composter that stays in the corner of our garden. Now, it hasn't gotten a lot of moisture lately, so it's pretty hard to gather, but this is what pure compost looks like. There's no sand mixed into this. Now, I wouldn't put this straight in, I wouldn't put seeds straight into this because, as you can see, it compresses, and it's not very friendly for the roots. And also, this is way more nutrients in it than any one plant needs. So for something like this, if I'm going to use this straight, I put just a little chunk, break it up, put it down in the bottom of a hole that I'm putting a plant into, or where I'm putting the seeds. And if I wanted to make a more general potting soil with this, I would mix it with some of the peat moss and the perlite. Like you can see here, this is used media from our hydroponics system. Now in here, you can see we didn't do a very good job of getting the fruit stickers off. And, but this is still a teachable moment for my students because I get to show them this does not break down. These are the kinds of things that we want to avoid using, these plastic stickers. Everything else, though, did a pretty good job. Except I think I did see some eggshell in here. That part's not going to break down as well either. But the eggshell's less of a deal because it's just calcium for your soil. Still good for your plants.
Okay, so now we will go back to the presentation and get ready to learn how to make your own worm bin. Next slide, please. Excuse me. So keep your questions coming. We will be addressing them at the end. And moving along, we have Rachel Singletary, and she will show us in the video how to build your own compost bin. So I hope you have the materials that we sent by email with you by now. And we can go to the video. Great.
Many classes to teachers throughout Lee County on vermicomposting in the classroom, on how to raise their own earthworms and their own worm castings. It's quite easy. There's a lot of scientific fact that goes into it. I'm not going to go into all the science of the soil, but if you're interested in more information, Teaming with Microbes is an excellent book on the soil web world.
And then on vermicomposting, Worms Eat My Garbage is an excellent book from the 1970s. The original worm lady wrote this book way back then. So there are basically different ways to raise worms. And the reason you want to raise the worms is to get the worm castings. Now, worm castings are not that high in nitrogen, but what they are is a wonderful soil builder. They have microbes in them that protect the plants. They're full of beneficial micronutrients and fungus, mushrooms, all kinds of microscopic organisms that you cannot see, but are there to create a wonderful natural fertilizer. Once you start using castings, there's no need to use the commercial fertilizer. Those are full of salts that are not good for the soil, so just stick with your castings. They're full of humus, and the humus extracts toxins and harmful bacteria and materials from the soil. So you can safely raise your own earthworms, and you've got a couple different options. So we're going to walk over to a couple of different examples of how you can raise earthworms. So the first thing you want to do if you're going to raise them in the classroom is get a bin. 33, 30 gallon, 36 gallon for the classroom is good because you have so much of a food source with the kids' lunch and cafeteria food, etc. So I would, and then you also want to raise a lot of castings. So the bigger your bin, the more worms you have, and the more castings you're going to have in about 3 months. So you start out with your bin. You fill it about 3 or 4 inches with Canadian peat moss. And you can buy a 3.3 bale of this for about $10 to $11. You'll have more than you need for the worm bin and for potting different seedlings in your garden. So when you get it, it's going to be very dry, and that would be way too dry for the worms. So you're going to put about 1/4 of the bin full of the dry peat moss, and then you're going to put about halfway up with water. This peat moss has not been soaking very long. You want it to soak for 2 to 3 days, and you can have the kids come along with a trowel and just keep turning it, or they can turn it with their hands. There's nothing in here that's going to hurt them. So you're going to let that soak, and then as it gets really wet, you're going to add paper. So this bin is halfway started. You can see that there's a lot of very wet peat moss, and then I added the dry paper. Now you can use newspaper, you can use all paper or all peat moss. You don't have to have it, but I like half and half because I know that earthworms live in soil, so I like to do half and half. And then also that way when the paper's gone, I know that it's time to harvest the worm castings, because the worms not only live in this worm bin, they also eat the paper. So this would be turned really well so that the paper is damp and soaks up all of that wet peat moss. You want your bedding to be 8 to 10 inches deep. You don't want it all the way to the top because you don't want to have curious worms go over the side. So 8 to 10 inches of bedding is plenty. And once you get this mixed up really well, you're going to squeeze it, and you want to be able to elicit about 5 to 10 drops of moisture. For the sake of time, I'm not going to finish this bed completely, but you get the idea. You're just going to keep mixing it and mixing it. And then when it's flat, if there's water in the corners, just add a handful of more paper to the corners until there's no standing water in the bottom of the bin. Now this bin is going to be in the classroom, so you do not want to put holes in the bottom. And you also, because you don't want it draining on the floor. And you can control the water and the dampness in the bin by using a watering can and just keep the bedding damp. That's all you want. Worms do not have lungs, they breathe through their skin, so the bedding has to be damp. It's better to be a little bit on the wet side than to be too damp. And then you do not use the lid. You want to use a piece of cardboard in here. Cardboard right on top of the bedding. You want to have a perimeter of open area. The cardboard keeps the bed damp and it keeps it dark, but yet there's plenty of space to get some aeration. You don't want your bin to be completely containerized or you'll grow mold and mildew. So in this bin, when it's time to feed, you're going to take a garden trowel, never a spade, and you just make a trough down the center because you're going to have a lot of different size worms in this bed. I use African night crawlers because they're such a good composting worm. They get very large. Whether you use red wigglers or African night crawlers, you want to have at least 300 or 400. Don't go to the bait shop and buy 12 or 20 worms. It's not going to be enough for a worm bin. They're different size worms, so you want to make different areas of food. If you put it all in one spot, the bigger worms are going to get more to eat than the babies. And it doesn't matter how old they are, how big they are, they all eat 1/2 their body weight every day in food. So you can use raw vegetables, you can use cooked vegetables, no meat, no fat, no dairy. And obviously nothing that would burn your mouth. You would not want to feed the worms, like jalapenos or something like that. You can use a few onions, some citrus, just not massive amounts. Their favorite food is papaya, and this is just a overripe papaya with some paper stuck to it. But you can put that in different spots because they all love it. Eggshells are good. I've got coffee filters, got tea bags, and any kind of fruits and vegetables, cooked or raw. Just keep in mind that worms do not have teeth. They have a gizzard. And you can put a little bit of sand in your new bin, just a little bit, so that the worms can use the sand with their gizzard to grind the food. If you really want to, you can chop the food up in small pieces, but you don't have to. It's absolutely unnecessary. There's other organisms that will be in the bin, such as roly-polies, pill bugs, sow bugs. None of these are bad. They're good composters. They're going to compost the food before the worms do, so those are good. You don't want ants, you don't want roaches, so that's why you cover the food up after you put it in the bin and the bedding, you cover it and you bury it 2 inches deep so that you don't attract any kind of unwanted insect. So that's what you would do with this bin. It's inside the classroom. Now, if you're worried about the classroom not having a lid, if you want to, you would still use a larger bin than this, but you would use the lid and you would drill large holes in it so that there's plenty of air circulation. And then you could just put a piece of screen over it and keep it closed. And that's for people that are maybe squeamish and worried about bugs. And if you feed your worm bin correctly, you're not going to have bugs. I've got a lot of experience with teachers in Lee County, and they're happy, and their principals are happy. Now, if you want to be like Littleton Elementary, they keep their worm bin outside. They use a recycling bin that Lee County quit using, and they do have holes in the bottom of their bin because this is kept outside. Now, this does not have any bedding in it, obviously, but it shows the holes, and you would put this on top of a couple of concrete blocks, fill it up with the same bedding that we would have in the classroom bedding bin, and then you put your cardboard on top of the bedding, and then just find some type of, this looks like an old oven or refrigerator grill that fits perfectly over that, and then you can use something heavy like a concrete block. That way no birds, no possums, armadillo, raccoons, etc. can get into that bin. The only thing that you have to worry about is maybe in massive rainstorms, you might want to put it under a shelter or something. If you're in Southwest Florida and Southeast Florida, you don't want it too wet. So that takes care of the bins. I wanted to show you the worms themselves. Freaking night crawlers. And you can see that they're prolific. This is a fairly new bed of about 4 weeks old. I used to raise worms for bait, and I used to feed them commercial food so they would get larger. Now I don't care how big they get, I just want them eating. And so these are happy worms. You can see what is called the clitellum, and that is their reproductive gland. Worms are both male and female, but they still need another worm to mate with. So if you see 2 worms tied in a knot, you know that they are mating. And what they will do is each secrete an egg capsule, and they each go away from the knot. And as they're sliding away from the knot, the sperm and the ovaries or the ovum fertilizes the egg capsules. You'll get 1 to 2 worms in every egg capsule, depending on environmental factors and what time of year it is. They seem to like fall and winter better than the heat of the summer, but these do very well in the heat. This is the finished product. You can see here the paper that I told you about and the wet peat moss, and you can see how wet that is. But here is a finished product. No more paper. Paper's gone, and what's left looks like fine coffee grounds, and it smells wonderful. It smells like earth, fresh earth in the woods if you were digging for worms underneath a tree. So these are full of the millions and billions of microbes I was talking about, and you can even see a few little critters that are crawling around, but those 2 are the decomposers, and they're excellent for your soil. So when you go to use this in the garden, you're going to use a tablespoon for a larger seedling, like a tomato. If they're small seedlings, a teaspoon per plant is plenty. And if you're planting seeds, you can't do anything better than to use castings along the trail of your new seeds. They germinate really well. So if you decide you want to buy castings, find yourself a supplier who uses a ventilated bag of some sort. Brown bags, if they're open, are okay. This is a bread bag from Publix, and what I do is put a cereal bag inside and put the castings in and weigh them, and then just gently fold over and staple it once or twice, so that when you get this home, it is still living. If you buy castings that are in plastic, you have no idea how long that plastic has been sealed, and especially if it's black and white plastic, there's no moisture, there's no oxygen, and there goes your living organisms that you're trying to introduce into your soil. So the one last thing I'd like to say is, in the classroom, you've got plenty of interested kids that will help you harvest your castings. So what you want to do is get yourself a plastic tablecloth or shower curtain, something to that effect. Something like this. This is late afternoon. This is perfect. You would dump about a mound of worms like this onto the tablecloth, and because it's not really hot right now, these worms are not going to suffer in the sun, but they don't like the light, so they're going to go down and they're going to hit the tablecloth and they're going to stop. And your children are just going to scoop up the castings, put them in a bucket to use in the garden, and then they'll be able to pick up all the worms that are on the bottom of the pile and put them into a brand new bin that you will have had prepared. So that's it. I'll be glad to answer any questions anyone has. It's just a really easy way to compost, and it's difficult to mess up on worm castings.
Awesome. Now we will get back to the PowerPoint. Great. So thank you for making this video, Miss Shelly, Miss Susie, and Rachel, who are with us now in the Zoom meeting. And you have the Google Drive where you can access all of these steps that they put together and other resources. Can go next slide, please. And next slide. So next slide, these are all resources that they put together so that you can review at your own pace in the PDF that we're going to share with you. Next slide. And if we can go to make a classroom version slide. Yeah, so this is also another tip that they are sharing with you all, and you will find it in the PowerPoint slides to be shared. And next slide, please. We also have this link where you will find more resources, and Kelly will be sharing it in the chat box. You have the teacher's email here. And next slide, please. So we are going to be wrapping up. And thank you so much to our speakers. This was great information. And today we have been introduced to the science behind soil, composting, and vermicomposting at school gardens. We got to see how to build a vermicompost bin, and you learned some tips from your very own teachers. So how great was that? And next slide, please. So this is the end of the presentation, and we will continue now with the Q&A session. Please complete our short survey. The link is shared in the chat box. Stay in touch with more tips and questions in the Facebook group. You know, the password is Cuban Oregano, and you will find the presentation slides and many other resources about soil, compost, and vermicomposting in the Google Drive. Link is also being shared in the chat box. And please register and join us for our next session on Tuesday, November 17, at the same time for our last fall session, Harvest and Eating from the Garden. So remember, it's next Tuesday. We're not going to be skipping 1 week. And the spring session, the spring series of this training is going to be February 2nd. So please save the date, and we will be sending more information later on. And next slide, please. The University of Florida is an equal opportunity institution. Next slide. So thank you so much for your time. We hope this is helpful. And now, Kelly, we take it over to facilitate the Q&A session, addressing the questions in the chat box and others that you may have.
Hello, good afternoon. Hi. Thank you so much, Carlita, and thank you again to our guest speakers and everyone who is participating today. So as you were typing questions in the chat, I have recorded those, and we can just go one by one in the queue that I have. But please feel free to continue adding questions to the chat or raise your hand by clicking on participants at the bottom, and then there's a raise hand function there. So if you have a question, you're also available to unmute yourself. I do see that Shelly has her hand raised, so if you have anything you'd like to say prior to question time, please go ahead.
All right, so at the last slide, we were saying you can make a classroom worm bin so you can observe the worms. So this is just a plastic container, and we taped some black cardboard or construction paper around it so the worms have the dark that they need. And so when you untape it, you can see their burrows and their activity. And you can actually see how long it takes for them to eat through a banana peel, for instance. So this is one activity we suggest. There are a lot of different AIMS lessons about doing worm investigations. So there are lots of things like that in the curriculum. There's also another version. This is a commercial bin that you can buy, and it actually has black sides that pull out, and then you can see all the worm burrows in it. All right.
Thank you, Susie. Do you have anything else before I move to the first question?
No, we just wanted to add that because it got cut out of the video.
Okay, awesome. Well, thank you so much. So the first question was for Dr. Wilkie, wondering if virtual tours of the compost lab, if that would be possible. Dr. Wilkie, are you still on the line?
Can you hear me now?
Yes, yes, we can.
I'm sorry. We don't have a virtual tour at the moment, but I think it's something we do need to do. I do have a couple of videos, one that Carlita made a couple of years ago, one that I made myself about the compost. Basically, I have 3 videos and a website on the process that I could share with anybody and be happy to if they'd like to see that. But I do realize it'd be nice if I had a walkthrough virtual. It would be great. I just need to settle down and do that. And maybe with the current situation with COVID, that's a really good way to proceed. That's a good question. Thank you. It encourages me to do that.
Yeah, absolutely. I know. I was excited too. And I know that there's a lot of people, you know, on the call today who are not close to Gainesville, so it wouldn't be feasible for them to necessarily come. But
I have 3 videos at the moment that I can share on a technical website. Yeah. I'll actually send that to you, Kelly, or to Carlita, and then you could share it with all our eager participants today.
Absolutely. Yeah, we will be sure to do that. Thank you so much.
Thank you.
So the next 2 questions are really similar. So you talked about what can be added to compost, but these questions were specifically about what should not be added. And so if there's any vegetables that are not recommended, and if there's just any other scraps in general, because if you're getting food waste or, you know, wasted food from the cafeteria, is there something that you shouldn't put in?
No, I'm a firm believer that anything that's organic can be degraded. I mean, I think, for example, there's a tendency for people to say a lot that, you know, you can't have citrus in your compost, but that's, in my opinion, that's not really correct. You don't want to dump a whole 5-gallon bucket of citrus in your compost. Everything is relative to proportions. Yeah, it's, you know, so I've seen people who've taken citrus from these juicing shops and stuff and then had problems with their compost. But I mean, they had more citrus waste than they had compost. So it makes no sense. So I think it's like with everything else in terms of our own diet, the bugs like everything in moderation too. So I can't think of it. I can't think of anything you can't add to compost, although I have noticed, like, it'd be interesting what Rachel and the others might say too. I have some sort of personal experience with not adding things like a lot of onions to worm composting because of the odor. But I really can't think of anything. I mean, I certainly wouldn't add any diseased plants or that sort of thing to the compost. That would not be a good idea.
Yeah, and Laura made a good point in the chat when she made the distinction between thermal composting, which is what we talked about first, and then worm composting, and that thermal composting will kill you know, your weed seeds and other pathogens and things because it's getting up to that higher temperature. But vermicomposting, you don't want it to get that heated because that will kill your worms too. So yeah, so you would want to make some distinctions when thinking about putting weeds or weed seeds into the different types of compost bins that you have.
Actually, I made a mistake in one of my slides. I had weeds on one of the slides. I have it must be a vestige from something. Take that out. Okay. I never put weeds into the compost. I tend to burn them and use the ash as a as a fertilizer. But the thing about it is with the weeds, yeah, 2 things. With the worms, it never gets that hot because worms are more like they're kind of moderates. They don't like to be hot. They don't like to be too cold. But in terms of the microbial composting, depending on the size of the pile, all the piles get up to a certain temperature for a certain amount of time. By putting in weeds, then you're under an obligation for a certain temperature for a certain amount of time to make a safe compost. So basically, my slide was wrong. Don't put in any weeds.
Thank you. Susie, go ahead.
Yeah, as far as the compost that we collected from the cafeteria, educating kids about what can go in is really important, because if they dump in milk or yogurt, then we have to throw out the whole bucket. So a lot of times we will get a lot of one thing, and if it's the day they have oranges, I can't put all the oranges in the compost because it's too much, because it's a whole 5-gallon bucket, just like Dr. Wilkie said. Most everything else is okay except for the hot peppers, like Rachel said in her video. So we try not to add too much of that even to the thermal compost. And we do have 2 separate piles. We've got the vermicomposting in 3 bins, and then we have 2 bins that are just the thermal compost. And then we have another compost pile that's actually out in our forest for most of the sticks and the weeds and things that gets nice and hot.
Thanks, Susie. Yeah, I think those points about proportion are really good. That makes a lot of sense. So if that didn't clarify your question, or if you have any other questions, feel free to put that in the chat related to what goes in and what doesn't go in. But the next question, which I think is great, is, are maggots suitable for vermicomposting? I have some thoughts on this, but I don't know if somebody else wants to take that question. Rachel, are you trying
I would
to
not use, yeah.
Go ahead.
Of course, flies carry diseases, so of course maggots are going to. So no, I would not. Now, soldier fly larvae are an excellent composter. So if you see what you think is a large maggot or grub in your vermicompost pile, it's really soldier fly larvae, and they're not the same as a housefly. They, you'll see them in a regular compost pile also. They're a very large black fly, and they lay eggs, and you will end up with a mess of what you think is a lot of maggots, but they are truly a super composter. You may have to add a lot of paper because they create so much moisture, but you can just pick them up and throw them out for the birds, because birds and chickens love them.
Yeah, definitely. So, yeah, when you're talking about maggots, it is hard to say because maggots are kind of more general in terms of like a larva of an insect, but black soldier fly larva is used readily for composting. But if you have black soldier fly larva in your worm bin, they will outcompete your worms for food. So if the idea is to create vermicast, is to create the worm cast, then you'll probably want to remove them. But if you do want to use black soldier fly for composting, you can probably create a separate bin and have them in there, because they, like Rachel said, they'll eat everything very quickly. So they are amazing in that way.
Okay. I can make a comment about maggots too, and that is that when we get maggots in our basically they're, you know, the fly larvae, when we get maggots in our composting, it's usually a sign that people haven't added enough brown material. So they've just dumped in the green food waste, and that encourages, you know, when the flies are laying the eggs, that's it's attractive. So if you actually want to get rid of them, if you try to dry it out and add some paper or cardboard, that usually does it. The maggots will eventually die and decompose anyway, which is good. And the other thing is, you can try to close off your compost bin so that the flies don't gain access by, I mean, it just depends. Maybe you have vents that you could put maybe some sort of small mesh in, or something like that. But usually for us, it's a sign, at least in the microbial composting, is that people have added food waste without adding, it's too moist and slimy, and that it's just attractive. Whereas if you add your food waste and mix it, or mix it so that the new deposited food waste is underneath the surface, there's no attractive surface for the flies to lay their eggs on.
Thank you.
And Shelly was also made the comment about soldier flies. I mean, there are people that actually grows soldier flies on food waste, and I think commercially they call those systems biopods, and you can just throw your food scraps into those, cultivate soldier flies, and then you feed all those grubs back to your chickens. It's for people that have food scraps, that's how they feed their chickens.
Mm-hmm. Yeah, a lot of protein for the birds there. But maybe not the best system for a school, maybe not the most suitable, but
no,
you can make that decision.
Yeah, I think it's just not as easy to manage. And
yeah. Okay, so the next question, I don't know if someone is currently experiencing rodent problems or if this was just a concern on the part of administration for not wanting to have a compost bin. So if, whoever you are, if you would like to clarify that point, please go ahead. But what ideas do you have to troubleshoot rodent problems or to avoid rodents in the compost?
So all of our bins here at school have a lid. It keeps the rodents out. So hardware cloth is the small 1/4 inch weave that keeps everything out. So the first one we built was a frame with that cloth all the way around and the lid locked with just a little twist lock, kept everything out. And then you saw the grill that we put on the vermicomposter. So always use a lid.
Thank you.
Yeah, I would say too, the other way to handle that issue, or let's say just call it a potential issue, right, is that you can raise some of the units that are available that are raised off the ground, and that you turn, then maybe you're not as likely to get rodents into them. The other thing is by not adding meat to the compost mix, that's a good thing. But let's face it, people shouldn't be throwing out meat anyway. Like we shouldn't, it's there's too much carbon and resources going into meat that we shouldn't be throwing it out. But anyway, a lot of people recommend, there's a generic kind of advice out there not to put meat into compost, and they suggest that is to reduce rodents. We've never had rodents at our facility, but managing the compost, and this Shelly and the others have said, keeping a lid on it and not having something that's odorous, that's attracting for the rodents, that's the key to keep. Just because you're dealing with food waste and other things that people think of waste doesn't mean it can't be all clean and looking good. So keeping up the aesthetics is very helpful.
Yeah, that's true. I think, aesthetics, that can be a good way to kind of get people on board with what you're doing. If it looks good, it stays clean, and you kind of pilot something small, make sure that you have that well managed, and that's a good way to go.
Well, I mean, we try to wash down the top rim and the inside cover of our compost bins once a week. We really don't do it once a week, but it just makes everything so much more pleasant to work with.
Yeah. So the next question is, does humus mean organic matter?
Okay, maybe I can answer that. It's not a difficult question, but here's what it is. Compost eventually becomes humus. You start off with dead leaves, twigs, trees, organic matter on the bottom of the forest floor, or whatever you put into a compost pile, and the material is degraded, and you're left with compost, which is a soil amendment. Once you take the soil amendment, the compost, and put it on the soil, it is further degraded. The nutrients are used up, and you're left with more a carbon residue. So humus is degraded compost or aged compost. Now, sometimes the terms are used interchangeably, but in the strict soil science sense, organic scraps or compost that you generate compost was a soil amendment that's added to soil, and after being there a while, it has no nutrient value left, just carbon, and then that becomes humus.
Wow, thank you for that really detailed explanation. That's very helpful.
As long as it was clear, it's something that I've struggled with myself because people use all the terms interchangeably,
Yeah, definitely. But knowing the like decomposition process and what the terminology is, that's very nice. I didn't know that.
We can think of it as elderly compost.
Perfect. We should just start calling humus that, elderly compost. I think that would clear things up.
Mature.
So the next question was, my concern about compost is the humidity, and what amount of water should I apply and with what frequency? And I don't know if that was referring to vermicompost or thermal composting, but with, vermicompost, you want that to be like a moist sponge, and then only applying any water with a spray bottle. But something to be aware of is that your food scraps will add a lot of moisture as well. So you likely won't ever need to water it, as you'll probably need to add more kind of brown material to your worms. But any thoughts on thermal composting and water?
Shelly, anybody else want to answer that? I don't want to answer all the questions. In other words, they have a lot of valuable information too. But I can.
So in dry season, we'll water it with a sprinkler. But in rainy season, we just want to make sure it is able to drain well. So it's pretty easy with the thermal compost. Just keep it damp, not real wet.
Thank you.
Yeah, and I would say too that another way to handle that is because the greens, like the food waste, has more moisture, and then when that material is even broken down, even more moisture is released that's bound up in the food, like an apple core or other things. So you can control the water content by adding the carbon material. Now, if you happen to add too much carbon material, and that happens, and then you say, oh, now I've got it too dry, that can happen. You can always just sprinkle some water on it. I would never stick a hose on it. I guess I'd probably get a watering can or something like that, or even a spray bottle. I don't know, just gentle moistening. Just think of it as like a facial application.
Lovely. Okay, so the next question is really interesting. Based on the type of waste that a site regularly generates, are there cases where it would make more sense to have thermal compost or vermicompost? So in other words, would there be a reason to have, or, how would you choose either one based on the waste, based on your feedstock, or would there be a reason to have both thermal and vermicompost, kind of, again, with that thought of what waste material you have?
So here at Littleton, we have both as a teaching tool. That the choice wasn't made from the feedstock. It was made so that we could demonstrate how each works. In my opinion, the vermicomposting is more exciting with the food scraps, but I really, I defer to Dr. Wilkie on this, but it seems like you can use both for both. It just depends on whether or not you want to work with the worms or if you want to work with making sure that it's at higher temperatures. My personal preference is for the vermicomposting because it is faster.
Yeah, I guess I would think, like, the question is different if you pose that, if that question was coming from a homeowner but if the question is coming from a teacher, right, for a school, in this case, then the answer might be just what was said in that for schools and for kids, the worms offer so much more science because it allows you to talk about soil amendment, talk about soil, talk about biology, talk about the bugs. There is also the excitement for the children and all the little wiggles and and get over their, getting them to play with the soil. So I think there's a lot. I think it's more exciting for the kids, I think, to do the vermicomposting. And from the teacher's point of view, it allows them to translate more of the syllabus into an action item for the kids.
Yeah, absolutely. Something else I wanted to add in regards to the kind of the benefits of both thermal and vermicomposting is from this fantastic book, the Worm Farmer's Handbook. So this is great, I mean, for anyone who wants to practice vermicomposting, but it does have some examples of larger scale systems, which if that's what your school is considering doing, there are really great examples in here. So but the one thing that the author recommends for a safer compost and for a compost that that the worms can eat more quickly is pre-composting your worm food. So yeah, you would basically do the same thermal composting process, but then heat up your compost to 140 to 150 degrees to kind of kill the weed seeds, kill any pathogens, and get the benefits of thermal compost. And then after about 3 to 4 weeks, that much of the material will have decomposed, and then the temperatures in the pile will begin to drop. So once the temperatures have dropped enough that it's not, super hot, you can then feed it to your worms in small layers, and the worms can eat it really quickly because the material is more homogeneous and broken down. It has all of those great microorganisms in the compost that you're then adding to the worms, and so you kind of get a more even worm compost by pre-composting your compost and then feeding it to the worms. So that's another option if you're doing both. They kind of get the best of both worlds there. Yeah.
I'd like to add.
Go ahead.
Thanks. I'd like to add real quick that our goal here at Littleton has not been to compost 100% of cafeteria waste, for example. Our system is not large enough to accommodate that. Our goal has been to run a healthy vermicomposting system. So to that end, with the water, with the food, all of it goes back to checking in with how the system is doing, getting in there and looking at, is it too wet? Is it too dry? There's not a strict recipe for it. It really is, you're making adjustments as you go. And you get a lot better at it as you go because you get used to what it should look like and smell like.
Thanks, Shelly. I appreciate you saying what your goal is. And if your goal, if your goal is teaching and maintaining this compost pile, then you do something different than making a massive operation to compost everything that the cafeteria is producing. So that's a really good point. So the next question is, which compost system, thermal or worm composting, is better able to handle larger volumes of material? Yeah, so which one is better for larger volumes?
I guess I would say it is, I suppose because I work with commercial systems as well, or interact with them. I mean, we're talking about a school system, or I guess the question.
Well, I think that Selena was the one who asked that question. So I don't know.
Well, here's what I think. It's easier. Okay. In my opinion, in my humble opinion, and just with my experience, and the other girls may have a different experiences, that worms, vermicompost, they like to have a very kind of regular diet. They don't like you to change the feed too much. So I would say that it's easier maybe to scale up the microbial composting, but the problem is then that you have to physically mix it. So you have to make sure that that's happened. Scaling up the worms can happen too. However, if you look at the commercial systems that are out there, there are not that many systems out there commercially that have scaled up food waste composting by vermicomposting.
Thank you.
And the system you referred to earlier, Kelly, I believe that book is by Rhonda Sherman from North Carolina. Yeah. And, you know, if teachers are going to have to thermally compost or microbially compost and then use worms on the same material, we want to try and encourage people to compost. And if they think they have to do both, it might be a bit of a deterrent, but some of the commercial groups do that. In fact, I work with a vermicompost company that they take dairy manure and they compost that the standard microbial way, and then they use that material as their feedstock for their vermicompost. But that's a kind of a commercial operation.
Mm-hmm. Yeah, and it definitely makes sense for them because they're trying to sell a very homogeneous product, right?
Yeah.
Yeah, I wish I could share the screen of the book and the pictures here of the different school garden vermicompost systems that they have. But yeah, most of the examples she shares in the book, they aren't necessarily doing the pre-composting, but she does share about it as kind of a gold standard for very, very high quality worm composting.
Is the book available electronically?
I am not certain. I don't know that.
You could get an electronic copy of the book and share with everybody.
Well, maybe we'll put a link in one of the PowerPoint slides. That way you can see if we find something. So the last question that I have in the queue, and if any more come through, then that is great, is that I have heard that to use vegetables from the gardens in the school cafeteria, we need to follow guidelines from school to farm, and the compost needs to be composted for a year. I'm kind of confused on this point and want to find out before starting compost at school. And I know that Shelly spoke a little bit to that, but just to kind of speak from guidance from the USDA and Florida Department of Agriculture and others, you know, the highest standard of food safety is to apply any composted material onto your ornamentals rather than to your edibles, just to be extra super careful. And so in that way, you know, you could compost and apply it to ornamental plants. But anyone else, does anyone else like to speak to that? Anyone on this call?
So when we were using the vermicompost, like Rachel said, it's only a tablespoon when you plant the seed or plant the plant, and that's all it really took. So we were okay to do that with the vermicompost.
Well, at our student compost cooperative, we compost, and because every time we add fresh food scraps, we turn the pile so it's continually being agitated, not the entire pile, but we wrap the new food scraps in the existing microbes, so it's always being activated as we add it, which gets the process started. I mean, we don't empty the bins on a regular basis, but we can generate compost and, you know, with food scraps and just paper and leaves anywhere around 30 to 40 days. And we would then cure it, but we put it directly in the garden there and then to grow things like lettuce. And at the moment we're using it for all the cole crops like cabbages and cauliflower, Brussels sprouts. So perhaps we're not following some regulation. Delete that.
Well, it's not, I mean, I don't know if there's like a regulation, but the different guidance you'll see in the Google Drive from Composting in Schools with from the Florida Department of Agriculture, the food recovery specialist there. She says, compost tips. USDA recommends for youth school gardens using food waste compost on ornamentals and purchase soil amendments on school gardens. And that's really just kind of the highest level of kind of safety and precaution that the Department of Agriculture is recommending. So yeah, that is what I have to say about that.
Is that Melanie?
Yeah, that's Melanie. So that's in the document here.
Yeah, well, I would say that there are a lot of people that are composting food scraps in their own backyard, and then they're using that compost in their own garden. But
Yeah,
it would be good to know if there's kind of, maybe there's not a regulation, maybe there's kind of like a best management practice or something.
Yeah, I think that, I mean, like no one's going to give you a fine. So I think it's more like that. But like Carlita said, we can definitely follow up with more guidance and more information in the email to kind of clarify this point. So yes.
And Kelly, I would say that vermicomposting would never be a problem in that way. I can see where the thermal might have that recommendation because there could be mistakes that are made during the process. But with the vermicomposting, you're going to know that the castings are ready to be harvested, and the worms, the anatomy and physiology of the worms take care of bacteria, they take care of metals in the soil. So I just don't think that that would be a problem at all in a school garden. And I would, you can research it if you want and find out for me, but I've never heard of that as far as vermicomposting.
Thank you, Rachel. Yeah, I do remember seeing something about this, like vermicomposting is discussed in the UFI Fisk Grow to Learn guide. So we'll just double check what it says there and, give you the page number and everything for kind of what the guidance is. But I think, yeah, we will follow up, and I really appreciate everyone sharing. And that is it. I'm sorry. I just assumed that you knew that that was the last question, even though I didn't say it. I just saw that I was done with my list. So that is all the questions that we had.
All right. Well, thank you very much, Kelly and Carlita and everybody else too. It's been a joy.
And a joy for us.
Yes, thank you everyone, and thank you for joining us today. We're going to make the recordings, slides, and all resources available to you in the Google Drive. So stay tuned and stay dry. Thank you.
Thank you.